Good morning to all. I'm Sumitra, working as an associate professor in EEE Department, RMT Engineering College. And this semester, I'm handling a microprocessor and microcontroller for third year EEE student. In this video, I'm going to Good morning. I'm Sumitra, working as associate professor in EEE Department of RMT Engineering College. And this semester, I'm handling microprocessor and microcontroller for third year EEE students. In this video, I'm going to explain about IC8279, which is keyboard and display interfacing IC. So before going to know what is the functioning of IC8279, first we need to know why we need to go for this IC. Even though we have 8055 IC, which is nothing but programmable peripheral interface, with that IC we can able to connect any number of peripheral devices, whether it may be an input or output devices to the processor. But at the same time, with that IC 8255, if you are interfacing keyboard or a display devices to a processor, then during that time the processor need to check the status of the keyboards, and also it has to refresh the display after each and every operation. So while doing so, it will be wasting its most of the time in refreshing the status and checking the status of the keyboard. So in order to overcome this only, we are going for this IC8279, with which we can able to perform simultaneous operation of keyboard and display interface. So for that purpose only, mainly this 8279 is meant, by means of which we can able to improve the operating speed of a processor, whether it may be an 8085 or 8086 processor. So coming to the features of this 8279 IC, it was designed by Intel, and it is having different operating modes when it is functioning in the input, whether when it is functioning in input mode or in output mode. For example, if it is functioning in the input mode regarding a keyboard interfacing circuit, it is having a capability to operate under three different modes of operation, like scanned input mode, scanned sensor matrix mode, and strobed input mode. At the same time, if it is going to function as a display interface, for example, a printer, then in that case, it is having two possible modes of operating, like left entry mode and then right entry mode, similar to that of calculator and typewriter mode. These are the different possible modes of operation possible when it is going to function in input or output interfacing circuits. Apart from that, it is also having an inbuilt debounce key, with which it is capable of generating its own key code whenever any key in the keyboard has been getting pressed. And it also provides the 16-byte display RAM to display the 16 digits, and it is having a facility to interface in 16-digit characters also. And it is also have an interrupt handling capability. So next, coming to the pin diagram of 8279, it is a 40-pin IC. The 40 pins can be segregated into four different sections, like CPU interface section, display section, scan section, and keyboard section. So for example, pins which are getting related to the keyboard are classified like this, which involves RL0 to 7 shift control bar STP. So these are the pins which are getting related with the keyboard section. And coming to the scan section, SL0 to SL3. So the four pins are getting related with the scan section. Similarly, coming to the display section, it involves out A0 to A3 and out B0 to B3, along with that BD bar called blank display. And then coming to the CPU interface section, which involves the various control signals like read bar, write bar, chip select, A0, reset clock, and DB0 to DB7, which is nothing but the internal data bus, which is of 8-bit wide, and also an IRQ, interrupt request, provided to the processor. So these are the pin uh, which are getting related with the four different sections of an 8279. The function I'll be explaining you in the separate video. Now, coming to the functioning of 8279, as I mentioned earlier, it involves four different sections, like a keyboard section, scan section, display section, and CPU interface section. So let me explain about each and every section in details. First, coming to the CPU interface section. So the CPU interface section consists of the data buffers, IO control and timing registers, timing and control logic. So first, coming to the data buffers, it involves the 8-bit data bus, which is a bidirectional one. With the help of that, we can able to connect this internal data bus to that of the processor bus. Then coming to the IO controls block, it involves the various control signals like chip select, read bar, write bar, and signals. Along with that, A naught also. So only with the knowledge of this value of A naught, we can identify whether data or the command word is getting transferred between the processor and 8279 IC. So the different values of the logic control signals which are getting related with the appropriate functions are, if A naught is 0, then it means that data, it is getting related with data. If A naught is 1, it means that it is getting, that is whatever communication it is leaving, that is it is getting related, which is concerned with that of the status word or the command word. If A naught is 0, it will be getting related with data. If A naught is 1, it is getting related with the command word or the status word. It may be either from the CPU to 8278 or from 8279 to CPU. So the flow of the data or the command word from the CPU to 8279 or from 8278 to CPU is decided by the logic signals read bar and write bar. For example, if A naught is 0, and write bar is enabled, that is write bar is 0 means it means that the flow of data is from the processor to that of the 8278. Similarly, if read bar is enabled and A naught is 0, the flow of data is from the 8279 to the CPU. And at the same time, if A naught is 1 and read bar is enabled, the command word is written by the processor to 8279. And if A naught is 1 and write bar is enabled, then the status word from the 8279 can be able to read by the processor. These are the various control signals which decides the flow of operation or flow of data or the control word, depending upon the signals. And then the timing and the control registers, and these are functioning based on the values of the signal in the line A naught. A naught is equal to 1 means the thing is getting ready to get programmed by proper writing the command word by means of the processor. Then timing and control unit, it consists of the counters, which is used for dividing the internal clock frequency, which is required for appropriate function to be happening. For example, if the parameter is getting involved as keyboard and time, and it requires 5.1 millisecond, and if it is related to the key scan time, it requires 80 microseconds, and for blanking time display, it requires 160 microseconds. For obtaining the different values of timings, we need to go for the counters, which will divide the basic internal frequency as per the requirements. And then coming to the scan section, it involves the lines, the pins like SL0 to SL3, and it is also having two modes of possible operation like encoded mode and decoded mode. What is the main difference between encoded mode and decoded mode is that in encoded mode, we don't have inbuilt decoder. So we need to go for an external decoder to select one among the four possible scan lines to give the active eye output. But in the decoded mode, the internal decoder itself is capable of selecting the four possible combinations like 1110, 1101, 1011, and 0111. So the thing will be getting activated according to the output of the internal decoder. And coming to the keyboard section, it consists of the various blocks like return buffers, keyboard and debounce control, FIFO sensor RAM, and FIFO sensor RAM status. Coming to the return buffers, we all know that a keyboard matrix is said to have the row and the column matrix. So where the return lines and the return buffers RL0 to RL7 are buffered, and they are getting latched by when each row scan the keyboard or sensor matrix codes. These are going to act as a row for both the scan mode and the sensor mode. So in the store mode, the contents of the return lines are transferred to the FIFO RAM. That is, whenever a key is getting pressed, the corresponding key code is getting transferred to that of the FIFO sensor. And then FIFO sensor keyboard and debounce and control circuit is the one with which we can able to generate the key code corresponding to the key being pressed. And then FIFO sensor RAM. So whenever there is an entry in the key, then the corresponding key code generated with the help of the debounce and control is getting stored in the FIFO sensor RAM. And then followed by the status, it will show the status of the FIFO sensor RAM, and this status of the logic will generate a IRQ signal indicating to that of the processor. And then display section consists of various display RAM, display register, display address registers. Display RAM is for just displaying the 16-digit display codes. Decoded modes, only first 4 locations of the display RAM has been used by 8279. In encoded mode, it uses only first 8 location of display RAM, and all the 16 location for 16-digit display have been utilized over here. And the address register will hold the address of the instruction or the uh, byte which is being currently executed or currently displayed. And display register, it is a 2 4-bit registers, namely A and B. They hold the 4-bit patterns of the character to be displayed. So these are the various functions of 8279, and the detail of the operating modes I'll be explaining in the next video. Thank you all.